All right, let's continue our discussion of the amniotes. So now that we've covered the general characteristics of the amniotes, let's talk about the various clades within the amniota, starting with the turtles. So the order Testudines includes all of the turtles, and I'm showing you a picture here of a common snapping turtle. So I'm going to tell you about just general characteristics of turtles. If you want to know more about those taxa that are currently or used to be referred to as the reptiles, you can take herpetology. And the same is true as we go through the mammals and the birds. If you want to know more details about them, I strongly encourage you to take the course mammalogy or ornithology. So turtles are unique based on a number of different characters, and what I'm showing you here are some cartoon slides of the internal anatomy or the skeletal structure of the turtles. And what you should notice immediately is that the ribs are fused together, unlike what you find in most mammals. And they're also, of course, fused to the vertebral column. Now, ours are attached to the vertebral column as well, but in the case of turtles, their vertebrae are in their back are also all fused together, so they have no movement that they're capable of in their backs. So this is a very unusual and unique characteristic about turtles, and it's combined with several other things. As you well know, turtles are famous for having shells on their dorsal and ventral sides to some greater or lesser extent. And in the case of these images that I'm showing you here, that top shell is referred to as the carapace, the bottom shell is referred to as the plastron, and in this case it looks like it has a pretty complete shell from the standpoint of having nearly its entire body covered in the shell. In the case of some turtles or tortoises, the plastron may not actually cover the entire bottom of their body. Sometimes it's fairly reduced. In this image, they're showing you that this turtle retracting its head and neck into its shell. And while it's true that many North American turtles can do this, many turtles around the world cannot do this. There's a group referred to as the side neck turtles, and they are not able to pull their head into their shells. Instead, they turn their heads to the side and they hide their head and neck underneath the sort of roof or edge of their shells. For those turtles that can withdraw into their shells, many of them can close their shells all the way up, and they have really great protection from predators when they can do this. But not every turtle can do this. It's important to note that turtles are anapsids. So as you can see from this image, they do not have a hole posterior to their orbit, where their eye would be. There's an enormous amount of diversity in the turtles around the world. So turtles can be found around the world in a variety of different habitats. They're only not found in the most extreme habitats that are extremely cold. Many of them are aquatic, such as in this map turtle here. This is a species that you can find right here in Michigan. There are tortoises that are primarily terrestrial, such as Galapagos tortoises and Aldabra tortoises and others. This is a matamata, a kind of unusual aquatic turtle. It has a very strange head and some interesting adaptations with its shell. And this is a snapping turtle. There are two species of, two in the United States that most people are familiar with. The common snapper, which I showed in the picture earlier, and this is an alligator snapper. Generally indicated by the spiky bits on its shell. Now, turtles can eat a variety of different food items. Some of them are vegetarian and eat aquatic plants or algae and other material. Many are carnivorous and eat fish or small invertebrates that they can get in their mouths. And some are omnivorous and eat just about anything that they can get. As I mentioned earlier, tortoises, so that term is generally used for species that are terrestrial and on the land. And they have these adaptations, they have many adaptations for being terrestrial, one of which is that they have what are referred to as elephantine feet. So their feet look roughly like what an elephant's foot looks like. They have very short nails because of, they're being abraded off and they're kept short in that fashion. They're often bigger and heavier and have domed shells, although not always as domed as this one is. And they have a variety of adaptations internally for dealing with living on land and for eating food that's on land. Aquatic turtles have a tendency to be more rounded in their shell shape, so it's more streamlined for swimming in the water. They have webbed feet, they have long nails, among other of their features. And they're quite adept at jumping off into the water and then swimming around. If you take a turtle and you set it on the edge of a table, it will drop off the table every single time because it's expecting that it's going to hit water. It's not expecting to be on a table. Whereas a tortoise, if you were to put it on a table and let it walk along, when it got to the edge of the table, it would stop, look over, and probably not keep going. Turtles lay eggs. All of them lay eggs and hatch from eggs. But there's an interesting aspect about the reproduction of turtles and tortoises. I'd like to point out first that they do lay their eggs on land. So even the aquatic turtles lay their eggs on land. They come out and dig in sandy areas to lay their eggs. When they reproduce, males have an intromittent organ that's referred to as a penis. It's very similar to the mammalian form, and I note this because later on we're going to talk about species that or organisms that do not have that kind of an organ. And turtles are one of a group of organisms that exhibit what's called temperature-dependent sex determination. And what I'm showing you in this graph is how part of that works. So on the y-axis, we had the sex ratio, so the percent of males. And on the x-axis, we have the temperature in degrees Celsius. And what I want you to focus on is this green line right here. We're not talking about alligators right now, and these snapping turtles are unique, and I'm going to come back to that. But what this is showing you is that turtles hatch out at temperatures that average 26 degrees to about 31 degrees. Above or below that degree, they aren't capable of completing their development. Ooh, thank you. I'm having some coffee delivered to me. Thank you. So at these lower temperatures, notice what you're getting is 100% male. So that's what's indicated by that green line is from 26 to 28 degrees, it's 100% males. And then at temperatures higher than that, from say 28 to 31 degrees, you get primarily females, or at least once you get to the cooler temperatures, you get primarily females. So instead of it being genetically determined what the gender of the turtles are, it's temperature dependent. And there's a complex physiological process for how this happens, and we won't go into the details of that. But I just suffice it to say that turtles do have temperature dependent sex. And in the case of most turtles, lower temperatures produce males, higher temperatures produce females. Now what's interesting is that some snapping turtles do this a little bit differently. What this graph is showing is that there's not only a wider range of temperatures during which the eggs complete development, but it looks like at the lower and the highest temperatures in the range, you get females, but it's the medium temperatures that yield males. So lower and higher females, medium is males, but just in the snappers. Later on, we're going to talk about the alligators in this lecture, and notice that they're similar in pattern to the snapping turtles, but with a different range of temperature. So they hatch out, and again, these temperatures are average temperatures that the eggs experience during gestation. So the temperatures in the nests may vary a little bit, plus or minus a few degrees. And you can imagine that from the top to the bottom of the nest, there may be a difference in the temperatures as well. It's probably hotter at the top of the nest, and in the case of turtles anyway, and then lower at the bottom of the nest. That's a little bit different for alligators, and we'll talk about why when I get there. But you can see that at the lowest temperatures in the range and the highest temperatures in the range, you get females, and at the medium temperatures, you get primarily males. Okay, now I'm going to move on. That's all I'm going to tell you about for the turtles. Now we'll talk about the superorder Lepidosauria. So this is a group that includes the lizards, the snakes, and the tuataras. And here they are in the phylogeny here. So let's first talk about the features that all of them share. The first is a transverse cloaca. And I'm showing you a picture here. So here are some lizards, and here is what's referred to as their vent. And just inside the vent is the cloaca. Now, I think I realized over the weekend that if I didn't misspeak in lecture, I know I at least drew it funny. But when I drew the salamander vent, I think I drew it as being transverse like this, but that's not correct. And here's a picture. So they actually have a differently oriented, they have a laterally oriented vent, as you can see here. And in the case of most turtles, or sorry, most frogs and toads, they don't really have much of a vent. It's more like just a hole that's in their undersides. So all lepidosaurs have a transverse cloaca. They shed their skin generally in one piece, or at least that they shed it all at the same time. So it's possible that it comes off in pieces. And so, for instance, here's an image of a lizard that's shedding its skin, and it looks like it's either already lost the skin from the tail or it's about to come off. So sometimes it may come off a little bit in pieces like this, but nevertheless, it comes off all at the same time. And you're probably familiar with snakes losing their skins, and they lose it all at one time as well. Interestingly, lizards will sometimes actually eat their shed skin, and it's thought that they do this because there's nutrient value there and they're sort of reclaiming the nutrients from their shed skin. Snakes do not do this. So there's a number of skeletal features that are similar among lizards, snakes, and tuataras, one of which has to do with their ribs. They have extensive ribs that continue down their spine much further than do, say, human or mammalian ribs. There are a number of cranial features as well that they have in common, but I don't really want to go into those gory details here. If you want to know about those, we can talk about them in herpetology. So let's go into the two orders within the Lepidosauria. The first is the order Sphenodontida, and those are the tuataras. Depending on who you talk to, there's only a few species of tuataras. Most people recognize two. These are really bizarre lizards in that, for all intents and purposes, externally they look just like a lizard, so you might question why they aren't considered lizards. But one of the big features that lizards and snakes possess that tuataras lack are hemipenes, and I'm going to show you some pictures of those in the next slide. But hemipenes are the structures that the male lizards use to, and the male snakes use to inseminate females. And as it happens, all of the tuataras lack them. Instead, what they do is they just press their cloacas together and they transfer sperm between themselves, between males and females in that way. So the males transfer it to the females. All of these tuataras are also nocturnal, so they're only active at night and not during the day, which is also unusual amongst most lepidosaurs, although some geckos are active only at night. Now, these tuataras can only be found on a few islands off the coast of New Zealand and nowhere else. And so, as a result, they're quite strongly protected. They are endangered. And at times on those islands, they've been most threatened by introduced invasive species that have killed them and eaten them. But most of those have been removed now. Okay, that's all I'm really going to say about tuataras. We'll talk more about them in herpetology. Now, the order Squamata is the order that includes lizards and snakes combined. And the features that they share is a highly kinetic skull. So maybe you're aware, most people know that snakes can manipulate their skulls in such a way that they can consume food items that are much larger than their heads. But lizards also have some ability to do that as well and to move some of their cranial elements somewhat. Probably not as well as snakes can, but they can move it somewhat. They also both possess hemipenes. So a penis structure you can think of as being mostly like a hose. It's an enclosed tube. But hemipenes are different from many aspects. The primary one being that they, instead of being an enclosed tube, they have this sulcus, this little groove that you can barely see in this one, but I'll show you some more images in a minute. But they have a groove on the outside along which the semen passes and then from the male and then along this groove and into the female. So this structure is completely inserted into the female in order to fertilize her eggs. And in the case of lizards and snakes, those structures are species specific in their morphology. So they have all kinds of different looking hemipenes, and you can identify species of lizards and snakes on the basis of just their hemipenes. So for example, these are two different examples of snake hemipenes, and you can see how different this set is from this set. By the way, this is just one set of hemipenes, so sometimes they're bilobed like this, and sometimes they're unilobed. So each lizard and snake has two of these, one on the left side and one on the right side. Here are some images of some other lizard species, hemipenes. So sometimes they're unilobed, like these two. Sometimes they're bilobed, like these two. And again, they would have a left version and a right version of each of these. So they insert these into the females. You can better see, by the way, the sulcus drawn here in these line diagrams. So this groove right here, this is the sulcus along which the sperm flows. So instead of it being, a tube inside the hose, it's a groove along the sides. So all lizards and snakes have these, and tuataras lack these hemipenes. So within the Squamata, there are two suborders that are recognized, the Sauria and the Serpentes. The Serpentes are the snakes. So let's cover the Sauria first. So you can tell lizards from snakes on the basis of two primary characteristics, although there are many more, but these are the two that are most easily viewed by non-specialists. They have movable eyelids that they can open and close, just like we have. Snakes lack those. And lizards have obvious external ear openings on the sides of their head that snakes lack. So let me show you a video that sort of exemplifies those features. So this is a bearded dragon. Oh, right there. Boink. Oh, let me play it again. Right there. So you can see the external ear opening right here. And in just a moment, you'll see him opening and closing his eyes. So they're feeding him. There's actually several bearded dragons in this tank, and he's being fed. I hate to admit it, but he's being fed an anole lizard. I find that really troubling, but hey, that's the way it goes. Circle of life and all that. Okay, now watch his eyes. Watch his eyes. Watch his eyes. Oh, and you can see he's closing and opening his eyes right there. Oh, God, listen to that crunching sound. That's awful. Here comes, oh, there you go. Now you can really see him closing his eyes. Okay, I think you get the point, and I can stop watching the carnage. Okay, so lizards have eyelids that they can open and close, and external ear openings that you can see. And there's an enormous amount of diversity within within lizards, or within the suborder Sauria, that I'd love to share with you. But we'll talk more about that in herpetology if you take that. One thing I do want to point out, though, is that in this next slide, is that while most lizards have 4 limbs, they have 2 hind limbs and 2 forelimbs, there are some legless forms that superficially look like snakes. And to show you that, this is a video of the eastern glass lizard. Now you would easily know, once you picked this up, whether it was a legless lizard or not, because you would see its eyelids opening and closing, and you would see the external ear opening on the sides of its head. I'm going to turn this down a little bit. It's kind of hard because of the video. You can't actually see this lizard's eyes opening and closing, but you would see it. And these glass lizards are called glass lizards because their tails break off very easily if they're captured in the wrong way, not held securely. It's an adaptation against predation. The hope is that if the predator grabs its tail, it can break off its tail, it can run away while the tail is left wiggling, and the predator actually still gets a meal and doesn't realize that the rest of the meal has gone away. Okay. Okay, so that's all we're going to talk about with lizards. There's an enormous amount of variety or diversity exhibited by lizards in terms of where they live, their morphologies, their habitats. But again, we can cover that in herpetology. It's one of my favorite topics. The suborder Serpentes, the snakes, are distinguished from lizards by having a lack of movable eyelids and a lack of ear openings that are visible to the outside. They're quite famous for their extreme elongation of their body. and the rearrangement of organs within them. So, just to give you a hint of that, if you look at the internal anatomy of snakes, you can see that because they are this somewhat constricted tube, their organs have had to be rearranged a little bit to accommodate them. So, for instance, here's the the right lung here, and there's only a rudimentary left lung left because there's just not enough room for them. Similarly, here's the testes, but they're offset. One is here and the other is here. The one kidney is here, the other kidney is here, and so forth. So the organs have been rearranged to sort of accommodate being in a small little tube like that. Snakes also have a number of really interesting adaptations for consuming prey. So you're talking about an organism that lacks limbs. Although in boas and pythons, you can see the remnants of the pelvic girdle. They have these what are called pelvic spurs that you can see near their cloaca. But for the most part, they lack limbs. And so there are a number of challenges that they exhibit because they lack limbs. So they can't handle their food. They aren't able to grasp anything. And so in this image that I'm showing you, this is one of many egg-eating snakes. They're able to actually puncture the eggs with some processes that come down from their vertebrae in their neck. And they can puncture the egg, release the contents of the eggs, and then spit out the egg shells. As you well know, and even in this image, you can see that snakes can manipulate their skull so that they can eat really large food items that are much bigger than their heads. And I'll show you a video of that in just a second. Actually, I'll show it to you now. Now, this snake's not eating a gigantic food item, but it's bigger than its head. So it's being fed a pinky mouse. It happens to be a leucistic snake. But you can see it manipulating its food considerably there. So it's alternating the use of the right and left sides of its jaw to force the food item down. It's not adjusting its skull as widely as some snakes will do to get the food item in, but it's doing quite a bit of it. And I didn't show you this, but in the floor of the mouth is the esophagus. It's a tube that comes out just in front of its, just behind its teeth, and that allows it to be able to breathe and eat at the same time. Otherwise, its esophagus or its trachea would be cut off, and it wouldn't be able to breathe. Okay. Snakes also have some other interesting adaptations. There's a group of snakes that are referred to as pit vipers that have what's referred to as a pit organ on either side of their head. And if you look inside their heads, what they're able to do with their pit organs is that they can sense very small changes in temperature between the outside of their faces, the inside of the pit, and the outside of the pit. And so what that allows them to do is to sense food items, primarily rodents, that clearly have a higher body temperature than they do because, of course, all of these animals that we're covering in this lecture today are ectothermic. So they can sense them. They also have incredibly good eyesight, and they can combine that with the use of their Jacobson's organ in order to hunt down their prey and consume them. So pit organs allow them to detect very specific heat differences. And the Jacobson's organ is one that many people are familiar with, but they're not actually that familiar with how they work. Most people know that snakes will stick out their forked tongues, they'll sense the environment, taste it, if you will. They then retract it, and there are two little holes in the roof of their mouth that people believe that they stick the tongue into. And when they do, they're inserting them into this Jacobson's organ, which is directly attached to or connected to the brain, and that allows them to sense the environment around them, and so smell it and smell mates or prey or danger. Now, as it happens, this figure isn't exactly correct. So most snakes actually have in the floor of their mouths two little knobs, and what they really do is they take their there we go. They take their tongue, sense the environment, bring it in, and when they do, they actually wipe the tongue onto those two little knobs, and then it's the two little knobs that then go up into the Jacobson's organ to sense the environment. So let me show you a video that shows you a little bit more about how pit vipers feed. Let me turn up the...
strike at humans to protect themselves. But when they're looking for food, it's a different story. Venom isn't a long-range weapon. Getting close enough to take a shot requires more sophisticated tactics. This is a timber rattlesnake from the Appalachian Mountains in eastern USA. As the forest slips into twilight, the hunter heads into the woods. The first step in the viper's hunting strategy is choosing the perfect backdrop. Now, it's virtually invisible to other animals. But it can still see them, thanks to these extraordinary pits below the nostrils, which give the pit vipers their name. They pick up infrared light produced by any living thing. It's like being able to see in the dark. This image comes from a camera developed for military use. The Rattler's heat-sensing equipment is 30 times more powerful. To the viper, a warm rat shines like a beacon in the night. The rat won't see the snake unless it moves, whereas the viper is thought to use both eyesight and heat vision in a single view. It seems the dice are well and truly loaded. These cutting-edge fangs have special hinges and flick open at the last split second like tiny switchblades. And because they fold back down when not in use, they can be extra long for deeper penetration. The venom injection flushes the rat's skin with blood, so it glows even brighter. Even if it disappears from view, it leaves a telltale trail of heat behind and gives itself away with every footstep. Venom also makes it dribble urine, loading it with a powerful scent. So when the trail goes cold, the viper simply switches tactics and smells its way. In fact, its sense of smell is better than a bloodhound's. The forked tongue tastes the air in stereo, picking up odors for analysis inside the mouth. Each flick of the tongue creates a scented snapshot with the rat still in the frame. Even when the rat is dead, its trail of heat and scent lingers on. So, thanks to its tracking expertise, the viper can cash in on its investment of venom.
So they have some amazing adaptations there. Sorry. There we go. So snakes have some amazing adaptations for tracking down their prey and consuming them and sensing their environment. I won't cover too much about venom, but just for reference, there are two different types, general types of venom that snakes can have. They can have neurotoxins, which is what most coral snakes or crates, boom slangs, African snakes, like sidewinders, they often have neurotoxins. And what they do is they, when you've been bitten or envenomated, it usually attacks your diaphragm first. It will then basically shut down your diaphragm, and then if you're not in a hospital and or being given CPR, you'll then die from lack of oxygen to the brain. but it'll slowly start to begin to work on other organs in your body as well. So it'll first work on your diaphragm, then it'll work on your heart. As it happens, if you make it to a hospital, you have a very good chance of making it through just fine. They will have to put you on life support until your body processes the venom, and then they'll give you a number of different meds to help with that. But as long as you can make it to a hospital in a pretty short amount of time, you'll be fine. If you're hit with the hemotoxins, though, those cause necrosis to your the site of origin where you've been envenomated. So, in other words, it basically kills all of the muscles and the tissues in your body around the site of envenomation. And then, depending on how much venom you've taken in, it'll continue to basically rot away, those parts of the body and work its way, up to your heart and to your brain. So they can definitely be fatal. That said, once again, if you can get to a hospital quickly, they can treat you such that it won't be fatal, although you may lose, some parts of your muscle and tendons where you've been bitten, but you have an excellent chance of recovery if you can get to a hospital quickly. Okay, and then last but not least are the crocodiles. Now, the order Crocodilia includes alligators, crocodiles, and gharials, which you may not be familiar with, but are really interesting crocodilians from India and Asia. But before I get there, it's important to note that, remember, the crocodiles are usually included with these other taxa listed here because traditionally they've been referred to as the reptiles or the reptilia. But the reptilia is not a monophyletic group. Let me fast forward to the phylogeny here. So here you can see the Lepidosauria, and then the turtle, and then here's the crocodiles. But we've known for a long time, based on morphology and molecular evidence, that crocodiles and birds are sister taxa. Crocodilians are more closely related to birds than they are to other so-called reptiles. So we no longer recognize the group the Reptilia, and instead crocodiles and birds are recognized as the group Archosauria. And so I'm going to talk about, so your book doesn't do this, even though it talks about the Archosauria, it covers the crocodilians together with the rest of the so-called reptiles, and then birds are covered in chapter 19. Now, for the purposes of sticking with the book, I'm going to finish up the crocodilians in this lecture and cover the birds next time. But just bear in mind that the Reptilia is not a monophyletic group and that, in fact, crocodiles are more closely related to birds. Okay, but that said, what do birds and crocs have in common? So why are they sister taxa in this superorder Archosauria? Well, they have a number of different characters that they share. One is that they're listed as having an orbit shaped like an upside-down triangle. Now, this is one of the images from your book, and here's the orbit. And I got to tell you that, in my opinion, the images that they show you don't really accurately portray this particular characteristic. In my opinion, this looks more square than triangular. But I think what they're getting at is here's the bottom part of the triangle. The pointed part would be here, but just as it happens in this image, it's a bit rounded. The other feature that they have is an antorbital fenestra. So as you know, a fenestra is a hole in the skull, and in this case, it's an antorbital hole, meaning it's anterior to the orbit. So here's the orbit where the eye would be, and here's the hole just in front of it, which also happens to be triangular. So this is the antorbital fenestra. And in this crocodilian skull, that fenestra is actually right here, but as it happens, it's been fused with the orbit, but that's only in this one alligator species. In many other crocodilian species, you can see a completely separate antorbital fenestra. And then actually, in this bird skull, you can see the antorbital fenestra just here. Other features that crocodilians and birds share is the presence of a gizzard. So they both have a crop and a gizzard. As you know, birds don't possess any teeth, and while crocodilians definitely do have teeth, they're all sharply pointed and are primarily geared towards just grasping a prey and then swallowing whole giant pieces of whatever animal they've grabbed. So there's no chewing or manipulation of the food involved. So these are large food items that they're swallowing, but they need to have some way of grinding up the food for digestion, particularly birds, since they need to eat small amounts but regularly so that they can fuel their high energy bodies. And so the way that they do that is with this gizzard structure and also with the crop. And also both of them will consume small pebbles or rocks that will sit in their crop to help basically grind up the food for them as if they had teeth. In crocodilians and birds, they have a four-chambered heart with the ventricles that are fully separated. So if you recall, in many amphibians and in some lizards, there's a three-chambered heart. So they have a right and a left atrium, but they only had one ventricle. In the case of crocodilians and birds, they have hearts just like ours. So they have two atria and two ventricles. This image makes the right ventricle look very small, but it's just by virtue of the way that they've shown the slices through the heart. Both crocodilians and birds do show incredible amounts of parental care. Birds are, of course, quite famous for this, and you see it all the time when they lay eggs and their eggs hatch out and they take care of their young and they feed them and then they fledge them. But crocodilians do the same. They make nests out of rotting material, usually vegetative material. They pile it up quite high and lay their eggs within these mounds. They guard the mounds until the eggs hatch. And once the little baby crocodilians hatch out, they care for them for 1 to 2 years until they're capable of taking care of themselves, and then they wander off on their own. Crocodiles are unique from birds, though, in that they reproduce with a true penis. So they don't possess a hemipenis, and this is the penis right here, and that's what the males inseminate the females with. I already mentioned that they lay eggs, and you'll recall from previously in the lecture, crocodilians have temperature-dependent sex determination. And at those medium temperatures, they produce males, and at the lower temperatures and the highest temperatures, they produce females. Now, this is a mammalian skull that I'm showing you here because I couldn't find a good picture of a crocodilian skull to exhibit this, but they have a complete secondary palate. So this is the palate right here, and normally in life there's, of course, a membrane covering this on the inside of the mouth, and it covers this hole right here. And that's really important because without this secondary palate and that membrane, you wouldn't be able to breathe and eat at the same time. But all crocodilians, as well as mammals, have this secondary palate. In addition, crocodilians have dentition same as mammals and birds. Well, for the rare birds that actually have these, and those would be fossil birds. So they have teeth that are set in sockets. In the case of lizards and snakes, the teeth are not set in sockets, they're actually attached to the sides of the jaws. I mentioned temperature-dependent sex here, and actually this is incorrect right here. Oh no, this is right. So remember, cool and hot temps produce females, medium temps produce males, and also males will actually vocalize, primarily to advertise to other males that that someone has invaded their territory, that's their territory, and they want them to go away. But the young will also call for their mama if they feel they're in danger. So to show you a video that sort of exemplifies this. Oh, hang on. You probably couldn't. Oh, I've been talking all this time without this thing back in here. Oh well. So when alligators vocalize, they usually do it in sort of a guttural growl, and it's usually accompanied by those vibrations in the water that they can sense between each other as well. They're very sensitive in detecting vibrations. So that's pretty much all I'm going to cover regarding the reptilian groups. Next time we'll cover the birds.